Cool, so just as a little bit of expectation setting, I live in New York, which means I'll talk fast. I spent most of my life doing physics, which means I like graphs. And I want to give you a story that's going to move quickly. So I'm going to start by warming your brain up, and then we're going to dive in. So I want to start with everyone thinking about this quote here. I don't know who to attribute it to because I've heard it in lots of places, and that is that the rate of progress is increasing. So I want to think a little bit about what does this mean? The rate of progress is increasing. And so one way to think of this is to break the rate of progress and say, what does one step of progress mean? Well, I think it means something like this, which is to say, it's the time it takes from when we learn something new about the world that can make the world better, and then we do something with that learning to achieve impact with it. And so when we talk about the rate of progress increasing, what we really mean is that the time it takes for this cycle to happen is getting shorter. Now, to warm your brains up, new insight is what we all do here as a specialty, so I'm not going to start there. I'm going to start with something that probably we don't do, and that is how those insights get turned into impact. So two quick examples. So the first is, the insight is, here's how you make a better car. The impact of that insight is, now we have a better car. And now let's think about how technology changed the timing of this. Well, when cars were first built, they were built by hand, and it would take months to do this. We then invented assembly lines that turned months into days, and then we enlisted all of the robots that turned days into hours. And this means that over time, as technology was invented, the overall time it took to achieve an impact decreased. So this is one example. Quick second example here is now the insight is what makes a better story. And the impact is that that story now gets disseminated to the world and can have impact. Well, if we go back in human history, at first we just talked about it around a campfire. It could take decades for a story to make it out there. Then we figured out how to write by hand, and now our decades turned into just years. We then figured out how to make a printing press to replicate our writing really quickly, and now years turned into days. Then the internet happened, and now all of a sudden our news could be disseminated to us in hours, and then social media and Twitter happened, which means now it's only a matter of minutes. And so what you see here is that as each new piece of technology is invented, the timelines associated with accomplishing the same thing continually compress and reduce, in this case, relative to achieving impact. So this idea of how new technologies are invented and how those new technologies impact the time it takes to achieve something is what we're going to focus on here. But instead of focusing on how those create impact, we're going to focus on the time it takes to get to a new insight. Because a lot of what market research is we're trying to learn something new. And what we're going to think about is the timing. And specifically, we're going to put it on a graph. I warned you about this. And that is that on one axis here, we're going to think about the time it takes to surface that insight. On the second axis here is going to be time. Now, I want to put a benchmark here, which is to say, I want to put something that we relate everything to. And in this case, I want to relate everything to the time it takes to understand one person. So this means if I wanted to sit down with Mike Courtney and understand him, this is how much time it takes for me to understand one person. And then what I want to trace throughout time is the time it takes to understand 1,000 people, because this is something that is impacted dramatically by technology through the ages. Now, to tee up how we're going to think through this, I'm going to put together a little bit of an anecdotal story, and we'll start with a story, and hopefully it'll catch up to reality. And that's about how we understand 1,000 people. So I want to start in 117 AD, at the height of the Roman Empire, and I want to think about Caesar trying to understand a balanced sample of 1,000 people across his empire. Now, if I'm Caesar, I don't really have a whole lot of technology. I have horses, I have people. So how do I do it? Well, it turns out the most time-efficient way is to do something like this. I first assemble 10 people, talk to them for a week, make them understand my problem, ship those 10 people out. It takes about 22 days on average to hit a random point in ancient Rome by those travels. Then each of those 10 people now find 10 people in that spot, spend another week educating them. They now go out and each find 10 people that they now talk to. This now means I have 1,000 people that I've sampled about this topic. Then they reverse, they come back, they summarize, they come back, they summarize, and finally those 10 people who all have a deep understanding of their particular area of Rome explain it to Caesar. And all in all, this means that we're at about 4 months. So we're going to use this 4 months as our benchmark of here's the longest it will take, and this is with no technology. Now we want to look at how different types of technology reduce that amount of time. So there we are, 4 months, time to understand 1,000 people with Caesar. All right, so the next piece of technology, which seems non-obvious, but seems overly obvious, and that's a train. Why does a train change the timing? Well, it's simple. A train changes the amount of time it takes to travel. And when we were on horses, it would take us 22 days. Turns out those same routes with a train take only 2 days. And just like that, one piece of technology took us from 4 months to a month and a half, which turns out may not be far off the average of a decade ago, but that's another story. So we're now at a month and a half. Let's put that on our graph, and you're probably going to start seeing what's going to happen here. It's going to get shorter. But let's keep going. So now there's more interesting things start happening. So now 2 important new ideas enter the world. One of them is the questionnaire, which was invented at the Royal Academy of London in 1838. And this was a way to standardize the questions that were being asked of people. The second is 10 years later, the telephone was invented. And this now meant that I could communicate with people without actually being in the same physical space as them. Well, when I put these 2 pieces of technology together, what I get for our theoretical Caesar here is something a little different. Now Caesar can assemble 10 people on his team, explain the problem to them over about 7 days, prepare his questionnaire, and now each of those is going to go out and call 100 people apiece. And so all the middle layers that we had to put in place, we don't need anymore. And now they come back, they summarize it to Caesar, maybe spend 7 days putting together an ancient PowerPoint, and now we're at about a month. So ancient Caesar, now that he has a telephone and a questionnaire, now is achieving research in a month. So now's where things get even more interesting. What happens? Well, first really important thing that enabled everything else is that the digital computer was invented. This happened in approximately 1946, depending on how you think about it. And this was important because it meant that everything that was data could now be interacted with and analyzed and looked at and played with in a much more automated way. Anything that we could turn to code, we could do automatically, and that meant things could happen quickly. But we still couldn't reach people until the internet was invented. So about 50 years later, we figured out how to connect all of these different computers together. And like that, we had these machines that could communicate. We had these machines that connected us through a network. And this changed how we could interact with each other. So somewhere around that time, some clever person said, hey, this would probably work pretty well to do market research. And in 1999, SurveyMonkey was founded. Now, this is SurveyMonkey's page from, I think, the year 2000. So things weren't hyper sophisticated, but they had now thought to leverage the network of the internet, leverage the processing power of a computer, and begin to automate various functions of market research. And just to kind of bring us to this time, I guess you definitely cannot see it in this picture here. That is a question that says, what type of internet are you on? And the longest one right here says 56K. So this is in a time where dial-up modems were dominating the world. But even so, this changed fundamentally how research happened. Now, Caesar could spend 7 days on his questionnaire, send it out, wait 7 days for people to respond. It might be tricky, but theoretically he could do it. Turn around, maybe spend 6 days on his ancient PowerPoint, got 1 day shorter because he at least had some automatic graphs. And now we're at maybe about 20 days as the theoretical minimum for conducting research. So now we're going to start getting closer into the present. And as you see, something's happening here. So what happened next? Well, 3 important things happened. So the first of those was programmatic sample was invented. And I'm going to credit this to Lucid and Fulcrum. I don't fully know the history, but this is from 2010. They decided to say, wait, we need to build 2 things. One is a marketplace for sample, so I think very related to the last talk we heard. And the second was access to sample via API. Now, does everyone know what an API is? Like, show of hands, maybe? Yes, no? Okay, mostly yes is cool. So API is like a way for a computer to ask another computer for a thing. And in this case, it's computers asking computers for sample so that it can be automated. So put this in your mind. So now we have automated sample to some degree. We have APIs. 1 year later, this happened. So AI expert systems began to emerge. And this isn't AI as we think about it today. So this isn't the deep learning and machine learning of today. But this is, we're going to take the knowledge of humans and light up the world. We're going to take the knowledge that people have, imbue that knowledge into a computer, and now that computer is going to be able to some degree do what the human did. In this case, it's answer Jeopardy questions. Now, one, I think, clever company quickly combined these two things together to bring automation to market research. Zappy which was founded in 2012, said, we're going to take this programmatic sample, the ability to bring sample via API, we're going to combine that with the ability to take expert opinions or expert analysis, put that into a system, hook it all together, and now this is going to allow you to pluck a type of research off the shelf and have it happen in an automated fashion. And this was a really big revolution in how long it took to do research. Because now our theoretical Caesar, who's using programmatic sample expert systems on Zappy is going to be able to spend about a day preparing, because largely the survey is prepared, maybe 2 days in field because it's using programmatic APIs that call and sample, and a large degree of the analysis is automated, which means we're down to about a day to turn that into a piece of insight. So we sum all that together, we're now at about 4 days as the theoretical minimum to conduct market research and get our insight. And that's pretty darn fast. So this is the place where my inner physicist just can't help but saying, you know what, let's put a line on this and ask ourselves a question about where it's going. And what you see is something really interesting. It's this point right here. And what's interesting about that is that if we project this forward, what it looks like is the amount of time it takes us to understand 1,000 people is starting to converge to the amount of time it takes us to understand one person. So this is something that I've been obsessed with for quite some time now, and I tend to talk about it as far as representative intelligence. Representative intelligence means the ability to understand a huge group of people in exactly the same way in time I understand one person. But let me unpack that a little bit further. So if we think about the difference between understanding one person and understanding a group of people, in the best case, it looks something like this. On this side is my understanding a group, and I as a researcher am going to put together my questions, put them into a questionnaire, send it out over whatever the platform is I'm using, gather data from my respondents, and look at those insights. And maybe at best it's going to take maybe 48 hours to do this. But conversely, if you look at how we understand an individual, we're going to ask a question to that individual. 2 minutes later, we're going to know what they've said because we're talking to them. We're going to ask another question, learn what they said 2 minutes later, and maybe by the third question, we're asking something based on what we just learned. We're asking a question that's going to dive into a new insight or take us down a different path of reasoning. So what representative intelligence means is bringing us to a place where these two things become the same, where we can talk to a group of people and engage a group of people and we go back and forth with them on the same timelines we would with an individual person. Another way to look at this, we're having a party, I think. Another way to look at this is like this, which is to say representative intelligence is this intelligent agent that sits between us and a large group of people, that interacts with them and represents them so that we can hold a live conversation with it. And in doing so, understand that group in the same way we do a person. Now, before we get to the how, we need a few more pieces of technology to be invented. So the first one of these is that we need deep learning. And in 2013, deep learning really started to take off. For those who aren't familiar, this was marked by one important thing, and that was this ImageNet. So ImageNet is a big database of a bunch of pictures tagged by what is in the image. And for the first time in 2013, deep learning outperformed any other model to understand what was in the images. And this is important because it was a new way of understanding data. Specifically, it learned data as hierarchical compositions. So if you look at the different layers of a network here in understanding a face, it broke it down first into lines, learned how those lines turned into things like eyes and nose and ears, and learned how those eyes and nose and ears compiled to become something like a face. Now, this was good, but in the problem of representative intelligence, we really need to understand language. And so the next big thing happened in 2014, the next year. In 2014, Google released this paper at NIPS, which is the big conference on machine learning. and it was sequence-to-sequence learning with neural nets. And the important thing here was this was the first time they began really understanding language beyond just what a single word meant. So if you look at this plot here, which probably you can't actually see, those are sentences. So those are strings of words together where the meaning of them is derived not just in what individual words mean, but in the sequence and the order of how those words compose together. So this idea of composite learning was now applied to language. So it was at this time, now we bring to what I've spent the past 5 or so years on, which is trying to solve representative intelligence. And so what we did, we founded this in 2014 now, is focused on building a system where we could leverage all the recent advances in machine learning, specifically applied to language, and allow us to build a representative agent that you could have a live conversation with. And at the same time, that agent would be engaging with a large group of people. The idea being that now we have real-time, one-on-one conversation with a crowd. To give you a bit of a sense of how that works, it works like this. So moderator might ask a question to a group. 2 minutes later, we're going to have asked all of those people, analyzed all of their responses, found the one response which best represents them. We're going to let you click into there to get an idea of what was all of the data collected that led to that response. And we're going to do all of that in about 2 minutes, so a smart moderator is going to follow up with the next question based on what they just learned. Now, if we take the system and we go back to where we started, which was here with Caesar, and say, now what does understanding Rome look like if you have a representative intelligence system? Well, it's pretty simple. So on average, Caesar's probably still going to prepare for his conversation. He'll probably put some notes together. We find maybe about an hour's worth of this. Maybe hold a 1-hour conversation. This is the average amount of time that it takes to hold a conversation on our platform. And then this is the number I'm not super proud of, but we're working on it. And that is that he's probably going to spend about 8 hours turning that data and those insights into an actual report. That sums to about 10 hours as kind of a baseline for how quickly Caesar is going to be able to understand his 1,000 people. And so we throw this back on our graph here. You can see that there's this really clear picture emerging, which is that the time it's taking to understand people is compressing increasingly quickly to a point where we are almost at understanding 1,000 people at the same amount of time it takes to understand one. Now, we're not there yet, obviously. I think those who have used our platform will tell you phase 1, phase 2 are awesome. Phase 3 to get to a report still takes expertise and some work. But 10 hours isn't so bad. And now we get to all dream about the future, which I think is what takes us here. So I think we're not far off, whether it's us or other companies that you'll see here today, that are going to be approaching or potentially even crossing this line of understanding 1,000 people in the same amount of time it takes to understand a person. And I think the implications for that go well beyond my pay grade. They change how businesses work and how governments function and how we all do research, and that's probably a future worth looking forward to. So with that, I'll do a soft, and here's the end, and add one last thing because I've always been told I should add something interesting and nerdy to my presentations, which is, so this is Python code, but this is an example of something that we taught one of our systems to do, and that is we learned most people who are respondents don't always use words that are actually in the English language. As a matter of fact, a lot of times they make up words. Now, it seems like this would be an impossible problem to solve, but I, as a human, can make sense of all kinds of made-up words. So we said, can we train an AI system to understand a word it's never seen before that's totally made up? And here's a few examples. Meshify, which is obviously close to our hearts, yummy with a gajillion M's, and gorgeousy here, which is a term that one of the people on our team made up. And you see it actually to some degree can understand this. So it interprets, so close your eyes and hear the word gorgeously. What do you think comes to mind? You have there's some substance, you have an idea? So what our system here thought was it meant gloriously, delightfully, entrancingly, charmingly, broodingly, captivatingly, absorbingly, sardonically funny, which I don't actually know what that means. Radiantly beautiful and bewitchingly is what this word gorgeously means. So I only point this out to show you that perhaps AI is a little farther than you think it is in understanding some complex things, although admittedly in some places it's not quite there yet. So with that, I will end and say thank you and take any questions.
Maybe, thank you, very good. Thank you. Maybe I'll ask the AI question. So the algorithm behind the scene is, did you write your own algorithm or are you using some kind of a open source there?
Yeah, so I would say we wrote our algorithm, although we leverage a lot of open source software. So we run on TensorFlow, which is totally not invented by us. We have a few algorithms that we solve along the way to solve this problem. So things like one of them is semantic similarity, which is kind of what everything's based on. That requires knowing when two pieces of language that don't share the same words actually mean the same thing. A few other that allow us to do different forms of Bayesian inference and prediction of what people will say. So you'll see if you've used this before, one of the steps is we give people maybe 3 to 10 A/B choices of pairs of things that they can choose. Now, usually we have 1,000 possible responses, which means 10,000 possible pairs. We're going to get to show them 5. And so kind of the other interesting algorithm is being able to predict how they would vote on the other 99,994. And as of right now, I think we're approaching the 90 percentile in that prediction, which is it's kind of gluing a few different algorithms together to make that prediction.
So, hi. Hi, Andrew. So this is absolutely lovely. I figured I'd take advantage of the opportunity to ask a question, which is one of the things that comes up in the context of deep learning and AI a lot is interpretability. Right? These, as you and I both know, are doing a lot of stuff under the hood. But in this context, the ability to understand what the system is actually, what's coming out of it is really important. And I'm wondering if you want to say something about how you address that issue.
Yeah, totally. So this is a thing that we are constantly evolving. So I learned when I first jumped into market research from physics, writing down the equations that we're solving is maybe not the best way to explain it. So 2 things on interpretability. So one is interpretability of what the algorithm is doing. And we'll do this, in semantic similarity, we can do this by saying, type in a phrase, and we're going to show you all the things ranked by being semantically similar to it. So this is not looking what's going on in the black box, which is a bunch of weights of vectors, but seeing what the outcome is. The second thing that we do is, in doing all the analysis for this, when we come to this conclusion of this response actually best represents those 1,000 people, we give some numbers as to how we got there. And so what we're actually doing behind the scenes is learning a distribution of opinion for every possible answer to that question. So if you think of a bell curve, right, think from back in stats, the mean of that bell curve, we give it a name and call it popularity. It's just the mean of that bell curve. And what we're looking for is the response that has the highest mean. And then we compute what we call consensus, and that's just, is the bell curve really peaked or is the bell curve really flat? And that tells us whether or not that popularity score really represents the group because everyone has the same opinion, or whether that's just the average of 2 totally polarized different groups. Say we've learned that that's still sometimes can be confusing, and so we're working on things to make it even one notch simpler, but I'll hold off on that until we prove it works. So,
thanks.
Yep.
Really quick, what would you say are limitations of the way you do it versus the traditional or a Zappi store method? And then you didn't talk about cost. I would assume this should be less expensive, but is that really the case?
Yeah, so 2 questions. So limitations, there's lots. So one of them is that what you saw here is it's text-based conversation. So in large, that limits what it's optimal for. So for example, if you want to observe how a person uses shampoo in their shower, this is definitely not the tool for you. Conversely, if you want to see where a person's eyes are tracking on a web page, again, not the tool for you. So I think where this tool is good is anecdotally anywhere where if your customer was only one person and the way you thought was to best understand your customer was to buy them coffee and talk with them, then this is likely to work quite well. If instead the best way to understand them is to kind of hide behind a curtain and watch what their behavior is on something, then I would say that's where this is not the best method. So, and generally we like to see it paired with a method that's like hyper behavioral in its data. Yes, sorry.
So I was like, as you were explaining that to us, would this method be good for understanding like the different target markets?
Yeah, so I would say if used correctly, yes. Okay. So if your target markets So if the way that you wanted to distinguish between different target markets was that each target market thought differently about something, then the answer is yes. So I didn't show it, but we do automated segmentation, right? So you can say, take my group of participants, break them into the groups that within the group, they all respond and think the same. So if that's how you wanted to segment your market, was by how they think about the world and view the world, then yes. If you want to divide them by something else, like just by geography or something that would be there, we can do it on here, but it might be an overkill and you might find a simpler way. Yeah.
So this is not a question, it's actually an endorsement. Hi, Andrew, I'm Julie Witter-Schlack from C-Space. So we work with Remesh. And having moderated a lot of sessions, one of the things that's so terrific is the participant experience. Because typically participants are seeing a little timer on the screen, they're curious, we have the option of showing them what responses are trending. And it adds this kind of gamification element so that people really lean in and are really engaged and tend, I think, to provide higher quality answers because they want to do well. So just from for a participant engagement perspective, it's really powerful.
Yeah, I can add a quick note to that. I was just chatting with one of our partners here at 7Cs in Japan, and he was explaining that they looked at respondent drop-off rates and found them to be, I don't know, I don't want to misquote a number, but like very, very, very low. Even over, you said you did like 70 minutes or something of a live session and almost saw no drop-off. So I think it's, the participant experience is something I talk 0% about here, because I don't want to be too salesy. But certainly it's a thing that we've put a lot of time optimizing, because the value of an algorithm is only as good as the data, and the data is only as good as the people and the amount that they're engaged. So certainly that's like a first order thing we think a lot about. Awesome, thank you. Yeah, thank you so much.